Hello, our names are Schuttevaer
and Casper Bruns.
and we are going to do the video challenge for exercise 4 and we are going to show you how to solve two partial exercises. So for the first exercise we have a function which we define as x squared minus y cubed equals 0, and we have to find the derivative dy dx and dx dy in the point 1, 1. So here we have a sketch of the graph and we're going to have to find the derivative in that exact point. So what do? We can use the formula for implicit differentiation. So we say that dy dx is equal to minus fx over fy. So now we have to define what fx and fy are. So the definition of fx is the partial derivative of the function with respect to x. So we see that this part of the function will be derived to 2x, and because this part is now seen as a constant, because we are only differentiating with respect to x, we remain with only this part. Now we can do the same for f of y, which is the partial derivative with respect to y over the same function, which is x cubed, x squared minus y cubed. And now the first part, which is x squared, is a constant, so that will disappear. And the derivative of minus y cubed is minus 3 times y squared. So now we have the two parts for a function and we can fill it into the function for implicit differentiation. So now we can say that dy dx is equal to minus f of x is 2x over f of y, which is minus 3y squared. Now we see that those two minuses will cancel each other out, so we remain with 2x over 3y squared. And now we have our point, which is p is 1, 1. So now we can just fill in the variables into the function and we find that the derivative dy dx is equal to 2 over 3. Now we can do the exact same for dx dy, and then the function is a little different because it is minus fy over fx. And now we can just fill in the function again, and we find that, so we can get the fy part minus 3y squared over f of x, which is 2 over x. So the minuses cancel each other out again. So we remain with 3y squared over 2x. And now we can just fill in the variables again, which is again the point 1, 1. And we have 3 over 2. Now the answers we found 2 over 3 and 3 over 2. Something interesting about them is that they are each other's inverses. But this is quite logical, because if we look at the two functions, then we can say that 1 over dy dx is equal to dx over dy. So these are each other's inverses. So it's not strange that we found two answers that are each other's inverses as well. Now Casper is going to do the second part of the...
For the second part, we are going to calculate the formula for the tangent line in point 1, 1. And what we're going to do is use the standard function y is ax plus b, and we have found a already. It's because a is the same as dy dx, which is 2/3.
Yes, and this is because dy dx is defined as the slope of the function. And that's the same as what the a part is supposed to do.
So if we fill this in the formula, we get I is 2/3 x plus b. Now the only thing we have to do is fill in the points 1 and 1 for x and y to get b. So we do which results in eventually our formula is and it goes like this. And 1/3 and now we have found the tangent line, and this was the end of the fourth exercise.